All right, so today we're going to start talking about functions. I want to do a little recap of the overview that I went over yesterday. I'll try to make this as quick as possible. So this is for if you're new, or if you want to get a sense of sort of what we're going to cover Python-wise in Premium Prep. The big things to give you a complete set of tools to be able to start programming effectively and start really solving problems with code are going to be understanding your types, understanding and utilizing functions, writing loops, and conditions. In no specific order. I actually usually do conditions and loops in this order, but whatever. No specific order. There isn't as much a hierarchy to these, but we do sort of tend to follow this arc, where we talk about types, functions, loops, and conditions. So your types, these are different schemas, ways of laying out information differently, right? So storing ways of laying out, storing, and handling different kinds of information in a way that's appropriate for whatever kind of information it is, right? So for numbers, we have ints and floats. We also talked about bool, string, str. There are some others, and I won't go into depth in all of these, but for understanding any of these, and you can just I'm just going to kind of treat this like sort of loose notes, but for understanding any of these, we can we can develop an understanding for integers and floats in terms of the operations, that the various types of operations and kinds of operations that apply to those types, right? So for int, we have the int function and the float function, right? Both of these apply to both of them, in that in either case, they could be the input or the output. We have, plus, minus, times, divide, modulo, exponentiation, etc. And we looked at a few other functions and things. So there are various tools and things built into Python that will handle these and help us utilize each of these pieces of information, and we can sort of build essentially a list of all the things that we could use for those. So as you're going about understanding your types, one way to approach this is to approach it in terms of or let me put it like this. One thing to do as you're approaching this is to keep track of what various functions and operators utilize that type in various ways. Conditions we talked about yesterday. We have 3 conditional keywords: if, elif, and else. Elif is, of course, short for else if. If, so let's talk about the anatomy. We have our conditional keyword like if or elif. Then we have our condition, and then colon, and then whatever the body of the condition. So we can have in the body, we indent the body, and we can have as many lines of code in the body of the condition, or sometimes called the consequent. The consequence, if that condition is true, the thing we want to run. Else or elif will be checked given that the condition immediately above it was false. If that condition was false, then the condition in the elif will be checked until you reach an else, and then that condition, or else is just going to execute if all the prior conditions were false. In terms of structuring these, something that I notice, I mentioned this before, in terms of like structuring these, how do you know when to use if alone, or use multiple consecutive ifs, or use if elif, or use if else, or if elif else, or whatever? There really aren't, as far as I've been able to discern, I've never encountered like easy, straightforward, obvious rules about that. The the rule of thumb is don't make too many assumptions. The assumption you can make is don't make too many assumptions. Each problem is unique, and you need to think through whether you need a chain of conditions where only one of those consequences will be executed, or where if you need separate conditional chains where multiples of those conditions may be true. So we're probably going to get a little bit into loops today, because part of our lesson is concerned with lists, which will sort of relate with loops as well. Lists are another data type here. But for now, we're going to get into functions. So functions allow us to containerize code, or they act as a I'm blocking on the word, but essentially as a container for an algorithm. If I've got a 10-line algorithm that I want to employ in a dozen or 100 or however many times in my code, I don't have to rewrite it every time. I can just define the process once, and then what word we use is call back to that process. You can think about it. I kind of true nerd fashion. I think about it as, I use the word invoke a lot. I think that's a good word to describe it. So we can define it in one place and then invoke it in another place. I always think about it like a wizard's spell book. Um, I'm embarrassed even saying this, but it's like the wizard has the spell book with all the spells defined in it, and then you have to have the book so you know what the spell is, and then you have to do the incantation. You have to invoke or cast the spell, right? So we will define these, as it were, and then call back or invoke the functions later in our code. The definitions may be, the long algorithm, and then the invocations are going to just be a bite-size portion of that. So cool. Okay. So these are like containers for the code. I don't know why. There's a better way to describe this, but I'm blocking on it right now. Okay. This is fine, though. All right. And then loops, as we will find out either today or shortly, allow us to, quote, iterate, aka repeat processes. Cool. So that's how everything fits together. Today we're going to be talking about functions and lists, and probably a little bit of loops. Okay. All right, so where's local scope? Okay. So quick notes on Slack etiquette. Comment in the appropriate thread or channel if possible, rather than sending messages to the whole group. Use the 3 backticks to make a coding block. I've covered both of these before, but just a quick reminder. If you're commenting, or if you're sending messages in Zoom, it's kind of funny. It's both a bit of a distraction, and I'm not going to read it. I'm probably not going to see it. So if you leave your comments in the Slack thread, I will see them eventually. I may not get to them as soon as I see them, but I will see them and get to them as soon as I can. So please keep your comments local to the thread, and that helps keep the channel clean, as well as allows for just smoother interaction, allows me to actually answer your questions. And we can keep all the class comments in one place. Aside from outside of class, you're absolutely welcome to use the channel, do whatever you like. Yeah. And then the 3 backticks, I demonstrated this the other day, so I want to be clear about this because it really, really helps when you're sending in code for a breakout solution, or especially I'll speak for myself, especially for me, um, given that I have somewhat of a disability with reading and parsing text sometimes. Ironic that I wound up as a programmer, I know, but it does really help me if you send me code formatted in a code formatting cell, which Replit has or excuse me, which Slack has built in as a feature, or in a triple backtick cell, and that'll format it like it's in a text editor, and in that way, then I'm sure that the code I'm seeing is actually formatted correctly, or at least is formatted the way it was when you copy and pasted it, right? So sometimes different formatting things like white space will be changed if you don't do that. So if there's things with indentation, it might just corrupt your code if you don't put it in the triple backtick cells. So to be clear, the backtick is not the single tick quote, right? This is a single tick quote. This is a backtick. Hopefully you can see the difference. Hopefully that's coming through in Zoom. So the backtick key is below the escape key, to the left of the 1 key, above the tab key on most keyboards. If you're on a Mac, that's definitely where it is. Okay, cool. So quick review. No. And I'll put it in a formatted code block there for you. All right, here's a breakout. And I'll put 2 minutes on the clock. And when you paste in your answer, go ahead and paste it in a formatted code block, formatted with the triple backticks. Cool. That's your 2 minutes. And I'm going to okay. So I'll just go through this real quick. So what are the 4 scalar types we discussed briefly in the prior lessons? We discussed ints, floats, bools, and strings. What does print 1 over 100 to the, what is that, 100,000th give us in y. So remember, division gives us a float, and 100 to the 100,000th gives us a huge number, and 1 over that gives us a very, 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 very tiny float. So this is going to give us 0, even though the answer isn't actually 0, because it's a float underflow error, right? So Python, what we're doing is essentially pushing or trying to produce a number that's so small that Python can't produce it or can't represent it accurately with the standard built-in float type. What does 3 equals 3 evaluate to? So this expresses the value true. When I see this kind of expression, I see true, right? Wherever you see this kind of thing, you can see a true in its place, or a true and a false. If like one of these was a variable that you didn't know the value of, it was like a equals 3, it's either going to be true or false. Either way, it'll be a Boolean. And then what does 2 not equal to 2 evaluate to? Obviously, just false. Cool. We got another breakout. There's that. So overflow and underflow. And I do see somebody posting in the Zoom message. Go ahead and send me that message on Slack, and I'll try to get to it as soon as I can. Okay. So the question about overflow and underflow. So overflow happens with integers. Integers will overflow. It just means representing a number that's too large to be represented in Python, and I'm not even sure. I'm not even sure how to. We don't really talk about this because I think it's a pretty extremely massive number. Oops. Let me just try this. So if I do this, and oops. I do hear somebody has unmuted their mic. So go ahead and check, everybody, if you don't mind, to make sure that your mic is muted. There we go. That should do it. So I'm not sure if this number is any shorter. This appears to be the same. So I'm not quite sure how to demonstrate overflow. I may have just not put in a big enough number here, but the idea of integer overflow is that essentially there is a limit at which Python stops being able to really represent integers. You know, come to think of it, I'm saying this and I'm thinking, it might actually just know when to. It might actually just be smart enough to add bytes as necessary. And that would be something that Python would do. So I'm not sure about overflow in that case. Underflow, though, is where you have a number that is too precise to be represented in a float. So if I have this big, long chain of nines, I mean, the most accurate thing to do would be for Python to print out this, right? But if I run this, we're going to get 1. So this is an underflow error where you have, we call it an error. It's not really an error in the same sense as like Python errors, but we do often call this an error because it's a calculation inaccuracy. It's the amount of bytes assigned to representing floating point numbers is too few to be able to fully accurately represent this number. So that's underflow. The reason we mention it is not because it's something that you're going to have to, it's not like a mechanic that you're going to utilize all over the place or something. You're not really going to be up against this problem. Although someday you may encounter this kind of thing. This is the kind of thing, like, if you don't know that this is possible, it can be really confusing if you're trying to work on a problem where you have to represent a really, really precise floating point number, and it's not doing that, right? So this is just more of like, hey, someday you might encounter a scenario where this could be a problem, but it's not really something that will probably come up for you all anytime soon. Interesting. Okay, so somebody's saying that they just Googled it, that the int type is equivalent to the long type in Python 2, and there is no upper limit to the maximum value. Right. That makes sense. I do occasionally work in I really like low level languages like C and C++ and Rust, and I like dabbling in other languages. So sometimes I forget like which ones have limits and which ones don't in those terms. But yeah, so evidently ints won't overflow, but floats will underflow, and that's because I think the resources involved in preventing an integer overflow are pretty minimal. Determining, do I need a larger, more bytes to represent this larger number versus the way that floating point values are stored. I mean, this goes right down to the hardware of your machine. This is like your CPU is designed around these data types, around integers and these floating point numbers. So it can be, there are ways around this. There are ways to add precision, but the computational complexity starts to add up after a while. So so floats underflow, integers don't. Cool. All right. Moving on. So using print to output to the console, I might rewrite this as using print to display to the console, because I use the word output to mean something pretty specific regarding functions. However, it's pretty easy to see print as having an output, right? Like down here, in my console where things are being displayed is a pretty obvious kind of output, right? But I do want to make a distinction in terms of like strict terminology. I wouldn't say print has an output in the sense that I usually use the word output. So print so print has an output. Technically, it has an output of none. It gives back the data type none. So where, like if I see 3 equals 3, right, this has an output in that it evaluates to true, right? True as an output of true, right? Print's job is to display whatever you pass to it to the console, right? And that's a different thing than giving back a value in your program, right? And this is an important thing it's important to delineate this concept from what we think of as quote unquote output, or more formally a return. So yeah, so print is a function that takes the value passed into it and writes that value, meaning displays it, writes it to the console. Print is in your core tool set for checking what you expect is happening in your code. So this is like your primary sort of first tool that you go to, like things aren't behaving as you expected. Okay, start printing things out until you see the problem, right? So this makes your output visible, but it isn't itself output. Okay. The print function is fundamentally different from the return keyword. So we're going to get into functions here. We're going to talk about how functions return, meaning gives back or outputs a value. They return a value. Some functions return a value other than none. Print makes something visible to the console. So there's a difference between something evaluating or expressing a value, returning a value, evaluating to a value, versus being written to the output, right? In the prior example, right, 3 equals 3 expresses the value true, but since I'm not doing this in a print, it's not going to be displayed to the console. So print is only for displaying things to the console. Looks like we have a question here. When we have a breakout, would you please post it here? Oh yeah, sorry. Yes, I will. I see. Yeah, I'll post the prior breakouts in there as well. Or sorry, I think that's what you're asking, for me to post the prior breakouts that I accidentally posted in the wrong cell. But yeah, I'll get those. Oh, my notes. Yes, I will post the notes when we have another breakout. Sorry, I misunderstood that. Okay, functions. All right, now into the meat of things. So functions. So functions can be thought of as ways to create repeatable procedures. So the name function, name the function, give it parameters. Parameters are the inputs to the function, and then write your code. So things we need to consider when making a function: how to name the function, what to name it. Same thing with variable naming, right? It's important to give your functions and your variables good descriptive names that help you understand what they are so you can use them later. What the function expects us, well, I would say, to simplify this, I would say what it expects for its inputs. There are some other terms that we use for inputs, and I'll talk about that in a second. Arguments, parameters. We'll talk about passing arguments, which means to supply actual values as the input. So how we should name it, what are its inputs, what is its process, and what is its output. So this is a good time for me to bring this up. IPO. So anytime this applies to functions that are built into Python, some that we've seen are print, int, float, type. What else? I forget what other ones we've talked about at this point, but here's some examples. So IPO stands for input, process, output. And this is a simplified rubric. There are other rubrics that you may be familiar with or may encounter. Some are like input, edge cases, errors, process, mutation. There are other ways of looking at this, but this, I think, covers all the bases in sort of a simple package. When you're understanding a function, whether it's a function that's already built and you want to know how to use it, or you're understanding a function that you're building, you want to understand it in terms of its input, its process, and its output. And really, the two most important ones are inputs and outputs, especially with functions that are already built for you. The process, you don't really care. I mean, maybe you care, but in general, like, do you really care exactly what print does under the hood in order to display to the console? I mean, it might be interesting to know that, and maybe there's a scenario in which that's important, but when you're just trying to print something out, you don't really need to know how it does it. You don't need to know its process, just that it does it, right? And usually understanding its inputs and outputs kind of tells you what it does, right? So I could describe each of these in terms of their inputs and outputs, right? So prints, inputs, are any arbitrary expression, and its output is the results, all of the results of all of the expressions passed to print as the passed into the inputs of print. Integer is any, well, anything that can be cast to an integer, which is going to be a float or digit characters from a string. I think a Boolean. I might be missing something in there, but generally things that we can think of as being representable as whole numbers, we can give to the inputs of the int function, and its output will be an integer. Yeah, so part of its process might be, so the reason I include process here, even though it's not as, in my opinion, and the way I'm thinking about this, it's not as important as inputs and outputs, is it's sort of a catch-all for like, is there anything else that I need to know about this, right? And maybe you could do like, maybe you could add description, dippo or whatever, description, input, process, output, or something. So you could have a variation of this, but really the important thing is, as long as you're notating in your head what the inputs and the outputs are of the function, that's probably the most important things. And then process might be a catch-all for errors and mutations and just other things that you might want to know. So another thing that we might want to know about the int function is that if we pass it, like if I try to print int of hello, right? How do you cast hello as an integer? I mean, your guess is as good as mine. I've got nothing on that. And you might be able to think of something. You might be able to think of something rational that it should do, like, well, maybe we should go into like the ASCII character set and find the number, the ASCII code number associated with each of the characters. But then what do we do? There's multiple characters, so do we get the sum of those? Do we just put them next to each other, like casting the word hello as an integer doesn't really make sense. Even if you could think of some ways to do it, there's not an obvious way that this should work. So we might annotate as part of int's process, we might say, well, it'll give you a value error. It'll give you this value error if you try to cast something as an int that it doesn't know how to cast as an int, right? So things like that. So I can go through each of these and notate them by like what they take in their inputs, what they give us out as their outputs, and maybe I want to have a note on how it does it here and there. I want to have a note in the process. But these are functions that are already built. We've talked about kind of how to use these. So let's look at writing our own functions. And I'm gonna write factorial, and factorial's got a few things going on here. You don't need to understand everything in here just yet. You have a variable. Here's our function definition head. This is a loop that I'm writing for I in range. Notice range has the parentheses after it. Range is another function. We're going to do 1 to n plus 1, which will include n. And we'll say prod times equals I return prod. Okay, cool. So great. So now I have a function that will give me the factorial of some number. But notice, and this is really important. What I'm about to say is the important thing here is that there is no value given for n. What number is this taking the factorial of? We don't know. And that's what's useful about it. Is this is an algorithm that doesn't apply to a specific number. It's an algorithm that applies to a general value of n, right? So if I have a value of n, let's say my little number here is equal to 4, and I want to pass. I'm just going to call it num. All right. Now I want to know the factorial of 4. I can say num equals 4 factorial of num, right? So this says factorial of num equals 4. This is like saying factorial of 4. Either of these is acceptable. So I can do it with the variable name or the literal value, the actual int value here. Either one is fine. I could even put in something like num plus 3, or let's just do num plus 1, which is 5, right? So I can even put in something that expresses an integer that I might want to do factorial on, right? So so all of these, this is where I supply the information that I want to use factorial with, right? So we'll run this. And you know there's a lot going on here. So if this feels like a bit much, there's only a certain portion of this that I'm going to come back to that I want you to understand for today. And the rest of this, you'll be writing this function in a couple days. So if you're not there yet. Okay, cool. So factorial of 4, factorial of num, which is also 4, is 24 in either case. 4 plus 1 is 5. Factorial of 5 is 120. Okay, so this is our factorial function. So let's break down what's going on here. And I'll use a simple example, but I wanted to show you this example because it's still fairly succinct while also being fully featured. So let's look at a simpler example. So I have my, you know what, I should just, excuse me, let's do this. Okay, so let's look at a simpler example. We'll say def, and then, so we use this def keyword. Def is short for define, but notice I can't say define. I have to say def. Def is the word. Def, and then I get to name the function. And this is, the naming of this follows the same naming conventions as variables, or at least that's the way I do it. I believe, I'm like 99% sure that that's what PEP8 uh, um, advises as well, is or is to use the same naming convention. So I can just give this um, any name is fine. So I'm just going to call this my function, and then I put parentheses here. Now the parentheses are going to describe. We'll talk about paths here in a second, but the parentheses are going to describe what the inputs are. Now, not every function has inputs. Some functions don't have inputs. If you write a function that doesn't have inputs, you don't get to leave off the parentheses. It doesn't work like that. So if you have a function, if you write a function that doesn't have inputs, which occasionally you might, you still have to put on the parentheses and just leave them empty. Don't worry about them. Just leave them empty. You just don't put anything in there. Then after the parentheses, we put a colon, and that tells us that we're done writing the function head. And the function head includes the def keyword, the name of the function, and then the name of the inputs, right? And I'm using this word input. Input is sort of a generic term for this, and I think it's a more intuitive word to describe this. The actual term is parameter. So when we define a function, we call its inputs parameters, right? So I could say A, B are the parameters of this function. When we invoke the function, we call the inputs, we call them arguments. So if I print my function, and let's just return A plus B. Okay, so A plus B is, you all know what A plus B is. It's the sum of whatever the value of A and B are. So what's the value of A and B, right? There isn't a value of A and B given here, and that's correct. That is what we want. So, and I'm saying this because I see a lot of people do this thing where they try to say A equals 4 and B equals 10. They try to say it here, and this is actually valid code, although for different reasons. But this is not where you supply those values, right? And then I'll see a lot of people do, so A equals 10 and B equals 20, something like this. Well, now there's no point if you're gonna take these in as inputs. There's no point in taking them in as inputs if you're just gonna override whatever values they were, like first thing, right? So we don't want to, and I want to be clear about this, we don't want to override these values in the function. We want to do this outside the function, right? So after the function is over, so this describes a function called my function, which takes in two values and returns the sum of whatever those two values are. So let's pass those two values. So we'll call this this A and this B, and we'll pass these into our function here, this A and this B. Okay, so now I have these two variables. This A equals 10 and this B equals 20, and I'm going to pass those in. So this A I pass in first, and that's going to replace the identifier A. Its value is going to replace the identifier A. So this is sort of like, it's kind of similar to a variable in terms of its anatomy, right? Like a variable has an identifier. and a value, right? When we define a function, the inputs are the identifier only. It's just the identifier. When we invoke a function, it's the value only, right? Now, I say it's the value only, although I'm passing in these other identifiers, but these, I think of these as values. I think of these as having the values that I stated here, right? And of course, I could do this with 3 and 12. So I can reuse this. Notice now I have something, and I should probably call this something like add nums. I can't call it sum, by the way, if you're wondering why don't I just call it sum. Sum is already a built-in function. I just don't want to overwrite it. I mean, I could for this purpose, although it feels so unnatural to call something sum that I can't bring myself to do it. Okay, so now I can reuse this add nums function as many times as I want. And anytime I want to know the sum of two numbers, I can pass them into my add nums function. And you might be asking yourself, well, if you want to know the sum, like if you want to know the sum of 30 plus 12, you can just do this, right? And yes, you're correct. This function is so simple that it doesn't even need to exist because we already have the plus operator. But as you'll see, we can have more complicated algorithms, like as we saw in the factorial, right? Like, you know, I could in this example, I can just say a plus b, or 3 plus 12 or whatever. But in this example, I don't necessarily want to write, this is only 1, 2, 3, 4 lines of code, but I don't necessarily want to write 4 lines of code every time I want to do the factorial of something. I just want to write factorial. Okay, cool. So those are the inputs. So during definition, and I want to make a nice strong distinction between the definition phase and the invocation. I feel like I spelled that wrong. Apologies if I did. I'm not going to try to fix it. So this is let's do this. Definition, invocation. There we go. So when defining things, we call the inputs parameters. So A and B are called parameters. When invoking things, A and B, and I'm just going to say the inputs are called arguments. And we say the verbiage that we use to describe giving those arguments is passing. So I would say I'm passing the variable this A, and I'm passing the variable this B. So I'm passing it 2 integers to be summed, right? Yeah. So these are the technically correct terms, right? We have parameters when we're defining, and when we're invoking, when we're calling the function, we call them arguments. In practice, we just always use the word arguments or inputs. So this is kind of one of those funny things, like if you say like, oh, I'm defining this with A and B as arguments, like everybody's going to know what you mean. It's something that everybody in the industry says wrong and knows we say wrong, and you have to know it anyways. You have to know the correct way anyways. If you want just one word for these, just call them arguments, and nobody will never know the difference that you don't remember what parameters are after this lesson. So you can use the word arguments to describe a function's inputs, and it'll make you sound smart, and it works. But you know, it is important to, you know, whether or not you call these the technically correct terms, to have the distinction correct, right? The inputs during definition don't have values, right? So inputs don't have values here, right? So no values given. And there's sort of an exception to that when we'll talk about that when we talk about default arguments, but that's sort of down the road. So for now, we can think of inputs mostly. Inputs generally will not have values given during definition. Um, during invocation, inputs inputs do have values here. I'm just going to do this. Okay, so inputs don't have values here, and they do have values here. Another way of saying that, and I think a little more succinct way, in my opinion, is to say that parameters are generic. Oh gosh, I feel like my spelling is super off today, even worse than normal. Apologies if I'm butchering words. I'm so sorry, but so parameters are generic, right? Generic meaning that they describe a general thing, right? In this case, really, they're just describing the name. But during invocation, arguments are specific. So arguments are specific. This means that when you're actually utilizing, invoking the function, you have to pass specific values, right? So I have to, whatever's here, better evaluate to a number that can be added. Yeah, that's it, right? It can be an integer. It could be, you know, I could have an expression here that evaluates to a number, right? So 30 over 2 evaluates to a number. I can add to that whatever that number is, 15. So I could add 15 to 12 like this. But whatever I supply in here, it doesn't necessarily have to be an integer literal or a float literal. Literal is just the actual value, something that expresses itself, right? So 10 expresses the value 10. So when we write 10, we call that a literal, right? Because it expresses what you see, right? So for another example, true is a literal value of true. True expresses the value true, right? Whereas this a, right, this variable called this a is a value. It expresses a value, but it's not a literal value because it expresses a different value than you write down, right? So so whatever's in here, it just has to be some expression that gives me a number that I can utilize in my function here. So yeah, so those are inputs. I haven't talked about returns yet. So the return, when you see the word return, this is what this you can think of as output. And when I use the word output, almost always I will be referring to something that's returned from a function, right? When we talk about the output of a function, we're talking about the return of that function. So what this is saying is, so let's run this, right? So I expect this to give me 10 plus 20, that's 30. 30. This is, well, yeah, this 27 here. 15 here, and 42 here, right? This one's not as important because it's not really using our function. So notice when I print out these calls, it prints out the sum of these things, and that's because I'm telling it to return. So this return says, hey, wherever you're calling this function, whatever is after the return is what the function expresses. So we're learning this concept of some part of your code expressing, meaning giving back or outputting or returning a value, right? So when we want whatever value we want our function to return, we just pass it, or excuse me, we put it after the return keyword, right? So this is something that gets, it may seem obvious now, but it will, I remember it confusing me when I was first learning, and I've seen it. This is a really common pitfall, and this is why we had this thing about print and return being different. Return says what the value of your function call should be. Your function invocation has the value of whatever it's returning. If you, a print makes something visible on the console. That's it, right? So if well, let's look at this output, right? This is the output. This is exactly the output that I got. Okay, so if I print inside my function, which you can print inside your function. You can use print inside your function all day long if you want. But if I print inside my function, so notice I'm printing here, and then I'm printing the invocations as well. This is the output that I get for this, right? So I have all these none values here, right? And that's because if we delete this print, oops, if we delete this print and I just have A plus B, our function no longer has a value, right? So if you don't have a return in your function will have the value of none, right? I mentioned this, I think, the other day, but print actually doesn't have a return, so its value is none. So if you print, which you can do, its value is none. Oops, I just said the thing. I'm just saying print all the time. Okay, so we want this to return here, right? So so I'll tell it to return this, and then I'll print out the invocation. When I invoke the function, I'll pass it to a print call, which will show me what it returned. Okay. So back to that IPO rubric, right? Inputs are the parameters or the arguments. Outputs are what it returns. Process is however you go about doing that, maybe any errors or other notes. I really use process as just sort of a catch-all for anything else that I might find to be important about the function. Generally, I don't note much, if anything, for process, but it's good to have it there. So IPO it is. Okay, cool. So basic function structure. So we have the def keyword, the name. Notice they called it arg for argument 1, right? And technically this is a parameter, but call it an argument, and everybody gets this wrong, and we all know we get it wrong, and nobody cares. In here, and I just showed, the last example, I just had one line of code, but in the factorial example, hopefully it's clear that like we can put any code in here. We can put any amount of code, however much code we want in there, we can have. Okay, so function parameters. So function inputs, that are inside the parentheses of the function header. So sometimes this is called the head, and then everything, I think I failed to mention this, apologies. Everything that we want to be a member of this function, we indent under the head. And this follows the same indentation rules as when we talked about if. When we wanted the if, the consequential code to stop, we unindented it. And the same thing is true here. If we want the code in our function, if we want to stop, how do I put this? If we want the code that we're writing to not be in the function, we unindent it from the function. And as soon as something is unindented, if we indent again, we're going to get an error unless we have another function head or something. So we can't just arbitrarily put things back into the function after we've unindented. So okay, function arguments. So quote, pass in arguments into the parameters when the function is called. So when we call or invoke, call/invoke the function, calling and invoking are the same thing. I'm using those words interchangeably. So when we invoke the function, we pass in a specific value as an argument. Okay, default arguments. So this is sort of the exception to what I was saying before. If let's do this, add 10, right? So let's say I want to take in a number and I'm just going to return the result of that number plus 10. And so what I'm going to do here is default B to 10. And I'm going to return A plus B. This is virtually the same function that I wrote above, right? So what this is going to allow me to do is set a default value if I don't supply all the arguments. So in this case, I'm writing a function that takes in 2 arguments, but I can get away with only passing it 1. So if I pass it 2, it'll assume that the value of the second argument is 10, right? But I can override that if I want. Let's say I want it to be 100. I can just pass in a number to override that, right? So defaults are useful. I wouldn't think about them too much. If there's something that you don't synthesize from this lesson, you can drop defaults. For now, there's some really cool things you can do with them, but sort of later down the road. But for now, know that these exist and that they can be pretty handy. But they're not gonna, yeah. Anyways, okay. So this is how we can set arguments to be assumed if we don't pass a given argument, right? So let's see. I forgot to mention, right? Like if I call the function, if I define a function that takes in 2 arguments, there has to be values supplied for all the arguments. In this case, in the first invocation here, even though I defined a function that takes in 2 arguments and I only passed in 1, both parameters are satisfied, right? Both arguments are satisfied in that they both have a value because the second one has a default. The second one defaults to 10. So it says, well, if I don't pass something, go ahead and just assume that I wanted that value to be 10. So it's going to say, okay, well, I don't see anything overriding that 10, so I'm just going to use 10. Great. And then here we have a case where I want to override that 10, and pass in something. But I can't, since these both aren't defaulted, I can't do this, right? So if I try to call the function without satisfying all of its arguments, I'm going to get an error. And it says type error, add 10, missing one required positional argument A, right? So I left out an argument for A. It knows B is equal to 10, so B's argument, passing an argument for B is not required because it has a default associated with it. But it doesn't have a default associated with A. So if you don't satisfy all the arguments for a function, it's just going to throw an error. You're going to get this type error. Name of the function missing however many arguments that you didn't pass that are required positional arguments, and then it'll note those for you, which is nice and handy. You know, like if you're trying to, first thing I do when I'm trying to learn a new function is I, call it and try to get, call it without anything and see if it gets me this error and just kind of give me a hint about what its arguments are. And hopefully they're named better than A, so num maybe, right? If I call this num, then I know that this should be a num. So one required positional argument num, right? Cool. Okay. We got a question here. Somebody's asking, could pi or e be passed into the function as an argument? I think this was regarding, apologies, it's been a little bit, we've kind of departed from that, but that was regarding this function, I believe, when we were just talking about, when I was saying this could be any number. So we can pass in any number. Yeah, so pi and e are numbers. So we can absolutely pass those in here. If I wanted to bring in, I can say it or I can do it. Why don't I do it? Import math, and let's add math.e to math.pi. That'll do it. You ever wanted to know what the sum of e and pi is? I guess we're about to find out. This is probably like the number that's going to change the world, or I don't know. It's probably like a really cool number. But anyways, we're going to talk about importing libraries later, but just for context, this is a tool that's built in to Python. There's a whole library full of mathematical tools and special, irrational numbers, like e and pi. There's a square root function, things like that. But it's not included by default, so you have to, quote, import it. You have to bring it into scope. So we'll talk about that in a later lesson. You're welcome. Sorry it took me so long to get back to you there, but good question. Okay, cool. Default arguments. Okay, so again, I've said it twice, and now the material is saying it twice. So print makes something visible on the terminal. Return tells you what the value of your function should be. So they're different. I know how obvious this must seem to some of you, but this really is an easy mistake to make. Some function that takes an x, printing off x is not the same as returning x, right? So this says this function has the value of whatever x was, and this just makes x visible on the terminal or on the console. A quick intro into f strings. Oops, there's a little typo there. I'm not going to get into that right now. Sorry. This is meant to be single tick quotes, but this last one's a back tick. So we've been talking about strings. So strings allow us to represent bodies of text. F strings allow us to So F is short for format. So a format string, sometimes just called an F string, allows us to template in information or sort of dynamically put in information that we may not know what that information is at the time we write it, but it needs to be determined during runtime. So we can't determine during write time. It needs to be determined during runtime, right? So if I say this example, right, like let's do this. I'll just do this example. No, let me do a different example. Let's do this. Name equals Sally, and age equals 47. So Sally's 47, and let's say I want to print Sally's 47. Well, I might not know that the name is Sally and the age is 47 yet. I need values in order to do this, so I'm just putting in some arbitrary values here, right? A name and an age. So if I want to write a string that will print out whatever the value of name is and whatever the value of age is, I could say name is age years old, right? So the reason I wanted to show this is we're templating, we have a string, right? And I'm making an F string here. The way I make this into a format string is I just throw an F in front of it. I just put an F right here. And then wherever I want to format something in, I put in curly brackets. If I don't put in this F, if I just do this and I leave those, the F off, the curly brackets are just going to be characters in the string, right? Because why wouldn't they be? But if I put the F in front of it and make it into a format string, then whatever's inside the curly brackets is sort of like an escape from the string. And this is just regular code. I can run any arbitrary code here, any arbitrary expression I can put in here, right? So if I did, yeah, so name will template in the string Sally, and age will template in the integer 47, right? So if I do this, notice our output is going to change. Sally is 47 years old, right? So now whatever the name and the age are determined to be is Billy is 7. Billy is 7 years old, right? So whatever the name and age are, whatever those are determined to be in my code, my F string is still going to be generated correctly. And you might think, if you're familiar with string concatenation, like, well, couldn't we say name plus is plus, let's really go hog wild here. There we go. So we'll do the spaces in there too. So name plus space is space age. Oh gosh, I'm not gonna do the spaces. I'm nope, too hog wild. This hog is too wild for me. Okay. Is stir age plus years old. Okay. So name plus is has to be 2 spaces here. Stir age years old. Okay, good. So these should be the same. But who wants to do this? This is complicated and finicky and ugly. And this is nice and succinct, right? And notice here I have to cast the integer as a string so I can properly concatenate it. But here I can just pass the integer and it automatically converts it to a string for me. So it's nice. All right. So I've been using this word input. There is a function by the name input that takes in input from the console. So if I say input or input, I type in imp when I mean input all the time. So okay, so input, and we'll also print a message. So yeah, actually, let's do this. Name equals input. Please enter your name. And age equals input. Please enter your age. And then this is kind of a better example, kind of a great example of what I was just talking about, right? So in this case, if we don't know the value of name and age, which we don't, in this case, we don't know the value of name and age at the time we run this, right? So the value is not determined right at the time we write it. The value is not determined at the time we write it. It's determined at the time we run it, right? So notice in my console here, it says, please enter your name. Oops, I should have done this. Make it nicer. Save that. Okay, so my name is Clark. My age is 947. I know I don't look it. And Clark is 947 years old. Okay, so this is a good example where we don't know the values of these at write time, and we want to build something that will determine this at runtime, right? So input sort of does two things. Input's argument is a string to be printed to the console, like print. So it takes in a string and it's going to display that string to the console, so that as a prompt, so that the user knows what they should input, and that's its argument. Its process is that it displays its argument to the console, and B, it waits for the user. Waits for the user to input something into the console, and then returns whatever they inputted as a string, right? So notice when I put in my age here of 947, this looks like an integer. I mean, it's the characters of an integer, but let's print the type of name and the type of age, and we'll prove that they're both strings. Right, so even though age is looks like an integer, the age is a string, right? So input always returns a string. If I wanted that to be an integer, I don't know. Let's do something like half age. Please enter half your age. So now I have to do math on it if I want it to be age, right? So I want age to equal half age times 2. Half age times 2. So let's just run this. Okay, so Clark is 947,947 years old. So that's not right. That is not twice 947. That's the string 947 repeated 2 times, right? So I have to cast this as an int, and I can cast this string as an int because it happens to be a string of digit characters, right? All the characters in that string are digits, so it can express an integer. So we can do this. So Bill is 186 years old. Okay, cool. We got another breakout. We're running tight on time. I don't think we're gonna make it through everything. I'm gonna skip the breakouts. I'll say take it from this breakout as part of your homework. Just include that as part of the homework. So again, if you haven't heard, print and return aren't the same thing. Just thought I'd mention that real quick. Variable scope. Okay, so let's talk about when and where variables do and don't live. Sometimes it's good and sometimes it's bad. Okay, so I'm going to show you something that I don't want you to do. And it's a mistake probably a lot of y'all are going to make, and that's fine. But it's something that I want you to not do. So my function is going to take in b, and we're going to return a plus b. Python allows you to do this. In my opinion, and it is just this, because there are different paradigms about how to organize solutions and how to organize your code to work with different things. I really like Python as a language. This is one of my few things where I'm like, oh, I really wish it just didn't let you do this, but it does. We'll say a equals 10. My function 20. Okay, so put it in Slack. What's this going to return? And also put it in Slack. What do you think my issue is with this? And I will tell you my issue, but try to see if you can see it. Oh, I changed, sorry, in the print, I changed the B to 20, right? I did have B there initially, so I changed that to 20. Otherwise, good catch. A is global. Yep, A is a global variable. A is a variable that is available to everything. It's available globally. Yep, so 30. Yep. So y'all are correct. It does return 30. Behaves as expected. This behavior is not necessarily super out of the ordinary, right? You look at this, you're like, well, A is 10, B is something, right? B gets its value here at 20, so return 10 plus whatever B is. B is 20, 10 plus 20 is 30. That's pretty easy. So the problem that I have with this is that when you write a function, it should not reference any variable from the global scope. The reason is, like, what if I called this function add 10, right? Okay, well, what if I come down here and I say a equals 500, or just do 500. $520. So add 10 no longer adds 10. It adds whatever the value of a is. I could see, I hope this doesn't look appealing to anybody. This shouldn't look appealing. This is in general, in my opinion, a way to write confusing and difficult to manage code. So you can have a variable in here. You want to have a in here, right? So I move a in here. It is now local to the function, right? So let's look at another. Somebody mentioned, but a is global, right? So okay, so I declare a global variable a, I declare the function add 10. If I print a in the global scope, what's going to happen? Surprise, surprise, it's going to print 10 because that was the value of a. Nothing revolutionary is happening here. If I come down here, if I move a into being in the local scope, a no longer exists globally. Okay, so a is not defined. So if I make a equal to 500, it no longer, mutating some random variable no longer changes the way my function works, which is, and I'm going to frame this as my opinion, which it is, it's good. It's good that changing a variable doesn't change the way an algorithm works, right? So you might think, well, yeah, but what if I wanted to pass in a into the function here? Like, isn't that the same thing? If I pass in a, isn't that like the function utilizing a global variable? And it's not. This is not the same thing because I have control over the inputs, right? Like, I know what the inputs are, and I know that this function, the output of this function, should only change based on what its inputs are, right? So for a given set of inputs should always correspond with a given set of outputs, rather than having other things that you could do that may accidentally or purposefully create a change in some algorithm that should be fixed, right? The algorithm, you think about the algorithm in your function as like fixed logic, right? It works the way it works. It gives you the same output every time for a given input that you give it. There are coding paradigms that kind of break that rule a little bit. I don't like those. I tend much more to prefer what I'm talking about, and that's how I'm going to teach you all, is that to write functions in this way that the inputs should have a one-to-one correspondence with the output. Should correspond one-to-one with the output, right? So this is like that. This works like that. So I can change the value of a, and that will change what my function produces, but a is an input, and if I'm not getting the output that I thought I was, then I know exactly, by looking at the inputs into the function, I know all the things to go look at in my code that might have caused the change, right? Whereas if a is global, it's not clear, like this, it's not clear why my function isn't behaving as I wrote it, right? And I wrote it here thinking it would add 10 every time, which it would, provided that I didn't change a. But if I go around and I start changing a and passing in things into the function to add 10 to, nowhere here when I've invoked the function does it tell me what broke the function, right? So you could still, I promise you, the better way is to do this. And I also promise you that you can still write broken code. Don't worry. It's just that fixing it it's clear where you need to check. It's clear where you need to check where the problem might be. So yeah. So this is something I want you to avoid doing, is writing a global variable and then using that in your function. Now, I know some of you are going to do this anyways, and that's fine, but it's worth mentioning here as well. Okay, so let's be ultra clear about this. A out here is a global variable. It's available everywhere. A, when it's inside the function, is local, right? It's local to the function. Local means that it only lives inside the function, doesn't live anywhere else. Cool. Okay, so we have some more breakouts here at the end. So those last two breakouts, I'll just include those as part of your homework for next time. All right, lists. We're not going to make it through all of this today, but we're going to go as far as we can, and then I will cover the rest of it in the next class. So we will go through this material in class, though I do suggest reviewing it between now and Saturday. So what is a list? So a list is a collection of arbitrary values. So what are values? Values are things that I've been calling data types. They're actual values, right? So 55 is an integer with the value of 55, right? True is a value of true. It is a Boolean type with a value of true, right? False is a Boolean type with a value of false, right? So lists are themselves a data type. Lists are a data type. The way we denote a list is we use square brackets to delimit the beginning and end of it. So if I want a list of numbers, I can just do this. For those of you coming from other languages, you may be familiar with calling this an array. It's probably at least similar to the array that you're used to, depending on what language you're coming from. If you're coming from JavaScript, it's an array in JavaScript, array in JavaScript, and a list, to my knowledge, are exactly the same. If you're coming from like C or C++ or Java, I think Java's arrays are a little bit different, but similar. So this is a list of integers. I can mix and match. Here, let's just print off this list, my list. I can mix and match data types, so they don't all have to be the same data type. I could have strings and numbers. Whatever. I can even have other lists. So this is a mess, just kind of a lot of values jammed together, but just gives you an idea that you can have a mix of data types, and you can have any type of information in your list. So one thing that I want you to notice here, let's do a little bit of a different example here. Let's rewrite my list like this. Okay. 4, 3, 5. Okay. So we'll do this. So I put in 4, 3, and 5, and I get out, surprise, surprise, 4, 3, and 5. So lists are ordered. Their order is preserved. Their order will never change. You can count on the order that you put in the elements being preserved and not altered unless you alter it, which you can, and we'll get into doing that. Yeah. So that might seem obvious, the thing about it being ordered, but there are other types in Python that don't obey order in the same way. So order is actually a feature that we want to be aware of, its presence or absence. We want to know whether a collection type is ordered or not, and lists are ordered. Lists are also mutable. The root of mutable is mutation, which means to change or alter in some way, to mutate. So what this means is that we can change the list itself without actually Okay, we can change the value of the list while having it still be literally the same list in memory, right? So there are different ways of processing and dealing with information. Some of those ways will create duplicates and sort of, yeah, some of those ways will like give you different versions of something, but it's a different thing. But with lists, you can change the list itself, so that you can potentially save a little bit of memory. So mutability can be a useful thing. We'll talk more about mutability as things go on. So the way we can declare an empty list, and an empty list is a valid list. It's valid to have a list with nothing in it. Might seem like, oh well, I have to put something in the list, but we do this all the time. We start with an empty list, and then we add things to it. We'll go through some process and add things to the list dynamically. It's called accumulation, and it's a pretty central idea to a lot of programming problems. So we start with empty lists all the time. To do that, we just use square brackets. There are various other things that we can do, that we can cast to lists, right? So there's a function called list, L-I-S-T, L-I-S-T parentheses like this, and it returns a list. It takes in 0 or 1 argument, so I can, for example, I could pass a string, and I could cast the string as a list. Hello. And notice that breaks out every character into its own element in the list. Okay. Let's talk about the range function. So range, you saw me use this earlier in factorial. We talk about range with lists because range is a bit similar but a bit different. But there's enough, you'll see that there's somewhat of an overlap in terms of when we use a list and when we use range. So there is no range literal. A list literal is whatever is inside the square brackets. A range is technically a different type, although we can think about it as returning a list. So we can think about range as a function that returns a list, even though, to be clear, that is an analogy. Range does not return a list, but you can think about it that way for now. So range takes in an integer, 5, and it gives me a range of numbers between 0 and 5. That's how it works if it takes in 1 integer. If it takes in 2 integers, the first integer will be where I want to start the range, and the second integer will be where I want to stop the range. So this is going to be a range from 5 to 10, right? So this range starts from 0 and goes up to 5. This range starts at 5 and goes up to 10. We could change this to 7 and go up to 10. Oops. Something that I want to mention here, the numbers in the range that are actually included are going to be 0, 1, 2, for this one. For this one are going to be 0, 1, 2, 3, 4, and not 5. It will not include 5. But notice 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 is 5 numbers, right? So range 5 gives back 5 numbers, but it gives back 0 through 4. So it's something that you need to remember. Same thing with this, right? So range 7 to 10 will give me the numbers 7, 8, and 9, and it will not include 10. So the upper boundary, whatever number is being used to describe the upper boundary, will never be included. If we wanted to include it, we would have to add 1 to it, right? Now, of course, here I could just do 11, but there's times like where you have a number like n equals 10, and if I say n, but I want to include n, I have to say n plus 1, right? So that's the time to do a plus 1. So this will include 10. So range can also take a third argument. So it takes 1, 2, or 3 arguments. 1 or 2 or 3. So if we give a third argument, that will be the step. So let's do just a step of 2. This will start at 7, and it will take steps of 2 up to 9, and then let's just do 15 here. Okay, so 7 to 9 to 11 to 13. And up to, but not including 15. So we can't include 15. So we'll just do these ones. 7, 9, 11, and 13 will be that range. So the way we think about this is range takes start, stop, step. Let's do that. Yeah, start, stop, step. If it takes one argument, it takes stop. And and implicitly start is 0 and step is 1. If it takes 2, it's start and stop, and step is presumed to be 1, and then you can give it 3 for start, stop, step. Indices. Okay, indexing. So my list, I'm going to call it my LST equals a list of okay, so I have 4 numbers in this list. Each number has a location, right? So each, regardless of whether these are numbers or not, the items in a list we call elements. So these are the elements of the list, right? And let's just throw in a different kind of element just so we don't call this numbers, right? Right, so we'll just put in a string here, right? So I've got 5 elements in this list: 55, 77, 33, high, and 44. Oh, no. No Slack. No. Less features, Slack. Please. Okay. Sorry, Slack's just freaking out here. Okay. So I've got this list with 1, 2, 3, 4, 5 elements in it. So these are the elements, and each element has a numbered location called an index. The index starts at 0. So the first element is always located at index 0. So in order to access an element at a given index, let's say I want to access the element high here. So I need to go to index 0, 1, 2, 3. So I need to print my list at index 3. My list at index 3. So the way I ask for the element at index 3 is I specify the list that I want to index into, and then I put square brackets immediately after it and put the integer that represents the index of the element that I want. Okay, so high is at index 3, so I do list. The way we say this is list sub 3, or list subscripted at 3. Yeah. So my list sub 3 gives me high. We can run that and prove it. We've got a couple of questions here. There's a question about local and global variables regarding if local variables override global variables. Let's just take a second for this really quick. If I have A in the global scope equals 1,000 or whatever. I didn't type 1,000. 1,000, and then A in the local scope equals 10. A in the local scope is the value that is used. So if there's a debate between something in a global or a local scope, the local scope wins out every time, until you're back in the global scope, which case the variable from the local scope no longer exists, right? So A from the local scope no longer exists here, and A will be 1,000 again. So local scope local variables do override global variables. Oh, and then somebody's asking also, so all defined variables that are used within the function should be local unless it's passed. Yeah, yep. And I would even think of when you pass an argument, you could take a global variable and pass it as an argument, but then those parameters are local to the function, right? So you're still basically using inside the function. It's using all things that are local to it, either the parameters which are local or any local variables. So yeah, that's a good way to say it. Okay. What value type does range return? That's a good question. Range returns a range. I laugh just because it's kind of silly to say range returns a range, but range 4 to 10. So the type of range is range. Renage does not exist though. Range is a function that does exist in Python. Okay, so class range. We even though this is technically its own type, we kind of don't think of it as a type in the same way as everything else. I think of it more as a function that allows me to iterate through a range of things, and we'll see its use cases as class progresses. But you will become intimately familiar with range. That's a good question, though. All right. So hopefully this is clear about how to use your indices. Indices, I'll warn you. So indices are not terribly complicated. They are extremely important to understand, though, and they're complicated a little bit by the fact that they start at 0. You have to remember that they start at 0. You don't really have. I mean, when I say that, it's not important that you like do it right the first time. I have to trial and error my way into like figuring out list indexing because it can be a little funky sometimes. But just diligent use of the print function, and you'll get there. You get used to it. But it's something can feel a little finicky, kind of starting counting from like 0, 1, 2, 3, 4. I mean, it feels unnatural, but you will get used to it, and you will have to get used to it. You'd better get used to it. Let me put it that way. You better like it too. Okay, I'll shut up. Okay, cool. List membership. So testing for membership. So here's another Boolean operator that's really useful. A lot of times we want to see, let's say, print is for a member. Is it a member of, maybe I could have prime numbers. Something like this, right? So is 4 a member of these prime numbers? False, right? Well, maybe 7 is a member of these prime numbers. True. Okay, cool. So the in keyword can be used in this context to check if something is a member of a list, if some object is a member of a list. So if I want to see if something is inside of a list, I can say 7, whatever that thing is in that list. And this expression, I mentioned it's a Boolean. This is a Boolean. This gives me back a true or false. So a lot of times we'll use this in conditional checking. We'll say, hey, well, I've got a list of 2 or 3 things or 10 things or whatever that I know, if the state of this particular function returns or a variable state or whatever, if it's a member of these things in this list, i.e., if it's equal to any of these, then I know I have some special code that I want to run. So if you think about this, it's kind of like saying if 7 equals 2 or 7 equals 3, let's just do this. Right, so it kind of saves us a bit of work there, don't you think? Right, so instead of having to do this, and I'm not even sure this is going to work the same, but you get my gist, right? Like this is going to check if this is equal to any of these rather than just saying if it's equal to one of them at a time or something. So this can save you a bit of work at times. That's list membership. Okay, so slicing. Okay. Alas, we are out of time today. So next class is noon on Saturday, and we will pick up from list slicing. Sorry about going over time today. Yeah, 1 second. Let me pause the recording and we'll wrap up.